Hi everybody, my name is Andrea Fasano and I work as a principal software engineer in Red Hat in the OpenShift agent installer team. Welcome to this talk today where I would like to bring you with me in the journey that we had into shaping a new approach that hopefully could make easier adding a node, a worker node, onto an on-premises cluster. But before start, I would like to ask you if there is anybody here that ever tried to add manually a node to a cluster? Did you enjoy the experience? Okay, nice. But don't worry, there will not too much technical detail. I hope that at the end of the session you will have a good grasp of how this new approach works and if it's something suitable for your needs. First of all, let's have a look at the talk, at the points that we discussed today. In the first part of the talk, I will introduce you to the problems that we found existing in adding a node to an on-premises cluster and how we tried to solve them, and I will also give you a quick overview of how the new approach works, which hopefully could make it easier for you to follow the subsequent demo where I'll give you a practical hands-on on adding a node on the cluster. Then, in the second and final part of the talk, we will look at some additional topics that are pretty important, like customizing a node, or the special case where you would like to add more than one node to the cluster. Before starting, and to avoid any confusion, I would like to anyhow make clear what are the scenarios where this new approach makes sense. So we talk about on-premises OpenShift or OKD clusters. It works also on OKD, and I will use OKD for the rest of the talk. Some examples are small single node home lab cluster, or cluster that you could deploy locally for testing and development, but also production clusters that typically are placed in a disconnected or air-gapped environment. So typically where you don't have internet connection. In this case, you don't have typically the lack of an auto-scaling mechanism like in a cloud-oriented cluster, and however the expansion of the cluster, so adding a new node, is not a very frequent operation that maybe you perform several times per day. So in general we talk about user provisioned infrastructure, so yet another acronym, I don't know if you ever heard it, UPI, which essentially means that the user must take care in the environment of setting up all the relevant networking infrastructure, hardware, and so on for deploying the cluster. This is something opposite to IPI-style deployments where the installer takes care of managing all the rest. There are anyhow some notable exceptions, even in the IPI cases, for the bare metal, where, for example, the user doesn't want to provide the BMC credential, the baseboard management controller, for doing the joining. Okay, given that, let's start from the big question that motivated this talk. Why it must be really so hard to add a node to a cluster? I mean, in the installation area, we did a lot of work to make the experience smoother, automated, and as much as possible easy for the end user. Why we cannot do the same also in this secondary workflow where you need to add new workers to your cluster? There were several problems affecting this part. Let's have a look at them. The first one was at the time of when we analyzed the issue. There were several ways of doing the same thing, but in slightly different, complicated ways. There wasn't one single method to add the node to the clusters, and each one of the methods available presented a good level of hand-working, so the user had to take care of several pieces, and there wasn't a uniformed way of doing this. And it was confusing, of course, for the end user. The second problem was, apart some notable exception, like in the assisted installer, all the other approaches lacked of validation mechanism. Why is this important? I don't know if someone of you previously followed Mateusz Kowalski talk about NM state, where he was talking about the joy of missing small details in the networking configuration, which could cause your nodes to hang up maybe remotely. And the problem is that we know that on-premises environments are hard to manage. You don't know all the details probably ahead. Deploying a node in an on-premises environment may require to match hardware and networking requirements, and maybe if you do a mismatch, you can discover it after 30-40 minutes after running the workflow of adding a node to discover that it will never join your cluster, and this is not definitely a pleasant experience for the end user. So it would be better to know it ahead if something is about to go wrong rather than discovering at the end. The third problem, which in reality it's a couple of problems, was that all the available approaches didn't offer a way for easily customizing a node. And again, the node customization is a crucial part in the on-premises environment where maybe you would like to provide a static networking configuration when directly you boot the node. Otherwise, it couldn't even join the network where the target cluster is present. And almost no way for monitoring the process. So the user didn't have a centralized or simple way to look end-to-end the joining process and to discover if something went well. So, given all these issues, what are the pillars on which we try to shape and design this new approach? The first one was we want to implement it in the OpenShift CLI tool. The OC tool, it's the tool that every OpenShift admin or OKD admin uses for managing the cluster. So it's something already known by the admins. And of course, if you already installed the cluster, it's already available in the target environment. Moreover, it already provided a couple of commands for approving the certificate sign request. This is part of the normal process of joining a node in the cluster. So at the end, there must be someone that validates the fact that this node is going to be added to the cluster. So shaping this approach inside the OC tool was a natural choice to make it more conformant and more usable for the user that was already trained or knowledgeable in this part. The second pillar was, why don't we reuse the lessons, the good things that we saw worked in the installation part? Maybe someone, I don't know if someone of you ever used the agent-based installer here or the assisted installer. Yes. So what were the things that we saw worked well? The ISO approach, shaping everything with an ISO that you can easily manipulate, move from one environment to another, from a connected to a disconnected, was particularly appreciated. The pre-flight validations, so the fact that we tried to anticipate as much as possible issues that could prevent the final operation to succeed. And moreover, the fully automated approach. That was another fundamental pillar. The third one was we don't want to bother the user with the configuration. We already have a target cluster. The target cluster is our source of truth for the configuration. It can already give a good amount of things for preparing the configuration needed for the joining process. Why don't we get them instead of asking and bothering the user? For example, in case of the disconnected cluster, the mirroring configuration, it's already available in the target cluster. No need to bother the user for that. So on these three pillars, we designed the workflow, which was based on three simple steps. Step number one, you build the ISO. In this moment, you create a single ISO that contains all the ingredients for backing up the joining process. The second step was, let's boot the node. At this point, the joining process will start, and the user will not have to do anything else than monitoring how it goes, the joining process. And the third step was to approve the certificate signed request, which is something already present in the usual joining phase. Let's have a look at in details at each of these steps to understand better how they work. So in the first step, we build the ISO. Let's assume to have a compact OKD cluster with 3 masters. And the very first thing will be to run this new command, the node image create. So node image is the new command that has been added in the OC ADM command of OC, and it sponsors a couple of sub-commands. The create will take care of running an introspection into the cluster, getting all the relevant information for preparing the ISO, and if everything goes well, at the end it will generate locally the ISO. The second step, assuming you have a worker instance somewhere in your environment, which of course is still outside, it's just a simple node outside the cluster, is to boot the node with the ISO that we previously created. As I said, at this point, everything goes on automatically. The only thing we have to do is just to monitor the process, and you could use the OCADM node image monitor command. The monitor command will print on the console all the relevant events during the joining, so that the user could be informed immediately if something doesn't work properly. And again, if the joining process goes well, we can look at the final step, the CSR approval. At this point, we are at the end of the joining phase, and a couple of CSRs are created in the cluster, and then the user can use the certificate approve command to finally approve these resources and let the worker node join successfully the cluster. So, to summarize, we saw that 3 commands are just required for the joining process. The node image create will create the ISO, the monitor command which looks over the events, and the final certificate approve to let the node effectively join it. Let's have a demo time just to break a little bit the thing. Let me. Of course, I pre-recorded the demo because it takes some time. So, but we will go over the relevant point. Okay, so I created in this demo a simple single node OKD cluster. You can see it's one of the latest version. And let's build the ISO. Maybe over there, yeah. One thing is required. There is right now just one mandatory flag. Probably we will remove it in the future, which is the MAC address of the node to be added. In this case, I also have a virtual machine, which is the node that I would like to add to this cluster. So I'm going to take its MAC address, and I will use it as an argument for the command. As soon as you run the create command by specifying the MAC address, you will see that a number of events are printed in the console. This is the moment where the command is introspecting the target cluster to gather all the informations and baking them into the ISO. Let's move on. If everything goes well, at the end you will have the node ISO available. So in the second step, you simply take the ISO and boot the node. I will keep the virtual machine terminal available here just to give you an idea of what's going on. Here it's the ISO, it's loaded, and before booting it, I will run the monitor command by specifying the IP address of the worker node. In this case, I was in a DHCP environment, so I know it in advance. And I also added a timer in the background just to give you an idea of how much time it takes. And you will see that a number of events are getting printed also in the console. Let me stop it here. One note, as soon as the node is booted, the agent UI is shown in the terminal. This is one first important preliminary check because we try to verify if the release payload is reachable or not. Because clearly, if it's not reachable, it doesn't make sense to continue because the joining process will fail. The agent UI also offered the possibility to enter the NM state at UI for a last-minute tweak on the static networking configuration. That could be useful, for example, if you are installing this thing in a remote location and you figure out that you need to fix it without rebuilding the ISO. But if everything goes well, nothing is required by the user and the booting process will continue unattended. So let's move on, and as soon as the node is booted, it creates an ephemeral environment where the necessary services for joining the process, the node, are started. And we can see that in the console, let me stop it, a number of pre-validation checks are shown to verify that everything is working. So the underlying assisted technology that we use for that will take care to verify that, for example, there are enough CPU, enough memory, disk storage is okay, networking environment is okay, and so on. In case of error, you will see a message here asking the user to handle it. Let's move on. And if this pre-validation phase succeeds, we pass to the OS writing phase, so the OS image is written to the disk, and then the node is rebooted. At this point, the joining process continues. We can quickly go over to the point where the CSRs are shown. That should be somewhere here. Oh, sorry. Yeah. you can see that also the monitor process, it's showing up the name of the CSRs that you need to approve. And here, let's approve the first CSR. And we can see that the worker gets joined to the cluster, but not in a ready state, because you need to approve the second CSR. And then, once also the second is approved, the command will tell you that the node joined successfully the cluster, it's ready, and it completes successfully. So the worker is available for usage. Okay, let's go back to the presentation. So let me go over. So we saw very quickly the process of adding the node by specifying just one flag, but there are several other flags that you can use to further customize your node. One is the host name. Probably the most important one or relevant one is the network config path, where you can put a full nmstate config file to provide static networking for your node, and also some others to provide additional configuration. What about instead if you want to add multiple nodes at once? In this case, rather than using the command flags, the command offers the possibility to specify the list of nodes that you want to add in a YAML file, so in a declarative way. The same information that you provide on the command flags are represented here in a YAML format. So here we have the MAC address, and here we have the nm state for the node. But of course, you can also add other nodes to this file. And the neat thing is that you still create one ISO that you could use for all these nodes for letting them join the cluster. So you can create a YAML with 100 nodes. You get one ISO, and you put this ISO in all the nodes. So this just to give you the idea that the approach offers two different configuration styles. One is the command line flavor, which is obviously more recommended for when you want to quickly add a single node, and maybe you don't want to bother too much. And the other flavor is the file-based approach, which is more suitable for handling more nodes, can be saved on a VCS, and of course it's easier to put complex configuration for the node there. We spoke about ISOs, but it's not really true, because another flag that is useful to remind is the --pxc. So the command, instead of creating an ISO, will create a number of PXC artifacts in case you would prefer to boot the node using PXC rather than an ISO. So another convenient thing for the end user. Last thing that I would like to mention, what about a massive scale? So for we don't have yet a solid number on that, but what I would like to point out is that in this new approach, every node is independent and fully autonomous in adding itself to the cluster. So if you run multiple nodes at the same time, simultaneously, one of them fail, it does not affect the rest of the other nodes. So clearly, even if we don't have proper testing on this part, the bottleneck could be the cluster resources or the environment resources like the DHP server, but the approach has been designed to make every node independent. And we have reached the end. So just to summarize what we saw today, I showed you a new approach that hopefully will make a little bit less painful the adding a node on-premises cluster, which works well also for disconnected environment. It's available for OpenShift and OKD since 4.17, so don't try to use it before because there isn't. And one limitation that currently is limited to workers. We have a plan in future to extend it also to replacing control plane nodes, but for now it works only for workers. And I also left a couple of documentation reference both in OpenShift and in OKD if you are interested, where you could find all the details related to the concepts that we saw today. Thank you.
So I have two questions. The first one is, why do we have, in this case, you mentioned this step that we need to approve the certificate signing request, but in the API installation mode, we don't have to do this. So I was wondering if it could be possible to bake into the ISO something that comes from the trusted cluster.
Yeah, as I mentioned in the beginning, the typical use cases are for more UPI-oriented style. IPI, in IPI, typically you already have an auto-scaling mechanism. The only exception is maybe if you don't want to specify the BNC credentials, but in all the other cases, unless you have an auto-approver mechanism, you will still need to do it manually. So in that way, we cover it. But if you have something that auto-approve the CSRs, of course, you will not have to do. Just to note, we didn't do any work for the approval part. It's something already available if needed in the OC tool. We just added the node image commands.
And I have a small remark from the usability perspective. So you showed in your demos that it took, I think, up to 1 minute to have, or 2 minutes to have the pre-install checked, validated. And the last error message was that we couldn't reach the NTP server. But me, as someone who would have used that, I would, after this error message, I would have stopped everything and start to debug my network. I would never have thought I would need to wait 2 more minutes to get the NTP server access to it. So maybe we need some information that we should not discourage ourselves when we reach that.
Thank you for mentioning it. Of course, we didn't go in details on how it works internally, but we use an approach where in the very first boot, we create a live environment. So we run all the services in an ephemeral environment that runs only in memory, which takes a little bit to execute and to go over. And the only motivation for that is to start the installation process effectively on disk. As soon as the first reboot happens, the ephemeral environment is gone, so all the services that we started for commencing the workflow are discarded, and let's say that the normal joining process starts. So there is clearly a little bit of booting time initially required for setting up the
So I'm not sure if you understand what I mean. I was not actually complaining about the fact that it takes time. I was mentioning the fact that we display an error message which gets corrected by itself after long minutes, where people would never know, would never expect this to happen from this NTP.
For the NTP,
yes.
Yeah, the NTP is probably...
You know, so you're
yeah,
not
yeah.
We are not exposing that the system
yeah.
is still progressing,
Yeah,
is what
yeah.
I mean.
Yeah, no, the NTP is probably the only particular case because even if it's displayed as a warning, it is not a blocking warning. I didn't show you a negative case for time motivations, but if there is a validation that fails to prevent the installation to go on, a clear message is shown asking the user, please, this thing doesn't work, fix it. Now the NTP was an unfortunate case because unless, especially in a disconnected environment, if you don't have configured it, you will see this out of sync message appearing initially, and then after a while it goes away. Thank you.
First of all, thank you for the talk and also for implementing this feature. I think it's really nice that you're also giving some love to the UPI environments. I have a question not directly related, but somewhat, and that is when the node comes up for the first time, you have to approve 2 certificates. The first one is for the node bootstrapper and the second one is for the kubelet. And once the kubelet certificate comes in, you can see the host name of the machine, right? But you cannot see the host name of the machine when the node bootstrapper certificate request is coming in. You cannot even see an IP address or a MAC address or anything. Why is that? Because as a cluster admin, it's always a bit, something is requesting to join my cluster and I don't know what it is, but I need to approve something, you know, and there would be like a window where another kind of rogue machine could try to join the cluster. So I was always wondering why that is the case, that you don't have more information in this first certificate request.
Yeah. To be honest, I'm not an expert of the CSR part because it's the standard approach of it, not something that we developed or worked on, but we just took it. We simply try to introspect them. We have the knowledge of which is the node that is running, so we know its IP and we know its DNS name. So we have an heuristic internally to perform a best match against the certificate in order to find it. In that case, we will be able to show the message. We had a similar problem like the one that you mentioned, no? That the fact that when you try to add the node, it's not simple even to find what is the right certificate. And for this reason, in the monitor command, just to make smoother the experience for the end user, we tried to do a best match mechanism so that we can give you an hint on what is the name and you can simply approve it without bothering to. As I said, we try to fine-tuning and remove all the obstacles that made this experience not the most pleasant one. Hope it answers your question. Thank you.
If not, then let's thank the speaker. Thank you very much for your time.
Thank you.